Okay, so here's a couple more examples regarding concepts that we didn't quite cover yet in our class session today via Zoom. And that has to do with where a function is increasing and decreasing, and then also where are its local maximum values and local minimum values. So a function is increasing when as you move left to right on that function, it is moving in an upward direction. And a function is decreasing where as you move left to right on that function, the function is moving downward. So what you've always got to do first to be able to find these intervals is to determine where are your bumps and your valleys. Those are very informal terms. Your bumps are what we call local maximums or local maxima, and your valleys are what we call local minimums or local minima. So notice in this picture, that point B on the function is a high point in that particular zoomed in portion of the graph. So that is a local maximum, and it's the y value now that we're going to be interested in here when we identify the actual local maximum. C, on the other hand, is a local minimum. So that is the lowest point on a graph when you zoom in to just that section of the graph. And so we would identify that the local minimum is whatever the y value is at that point C. So in this picture, we can see that it's moving uphill from left to right as you move from an x value of A to an x value of B. And therefore, it is increasing from little a to little b. Then it turns around, and it always turns around at the bumps and valleys. So then it turns around, and from little b, the x value of the bump, to little c, the x value of the valley, it's going downhill from left to right. So we would say the function is decreasing from little b to little c. And then, of course, it turns back around. And as you move left to right on the graph, it's increasing from the point CD to D, but that's in the interval from an x coordinate of little c to an x coordinate of little d. So to find these increasing and decreasing intervals, we've got to find our bumps and valleys first. So in this one, we would want to sketch the graph of the equation in our graphing calculator. And I just zoomed into a window on my calculator, and this is what I see. Now in A, it asked me to first just sketch the function. There it is. That's what I see with the help of my online graphing calculator. In B, it's asking me for the domain and the range. Well, we know that in reality, this graph is going to keep going forever further to the left and forever further to the right. So the domain is going to be all real numbers. But the range is about the height of the graph. Those tails are going to continue to point downward onto negative infinity. But the highest point on this graph is right here at this bump. And on my graphing calculator online, I determined that that bump was where x was equal to 2. And I saw that the height of that bump was 32. So since we're talking about range here, we would identify that the range reaches a maximum height of 32, but goes on forever to negative infinity. And that's why we see our range is identified from negative infinity to 32. The infinities and negative infinities always get parentheses, but we can see that it actually does reach that height of 32, and that's why the 32 gets a bracket.